Good evening everyone. My name is Sajid Ahmed. I am from Srinagar, Jammu and Kashmir. I have completed my BE from SSM College of Engineering in Civil Engineering. I am currently teaching at DBCC Coaching Center. I have been teaching here from last 5 years sidewise, and my subject is science and I am oriented towards physics. And I have chosen the topic as light. As we are all aware of the definition of light, that light is a form of energy which enables us to see objects surrounding us. Just like this, for example, I am capturing a video right now. If light is here only and only then I can capture the video in good quality. Now, the astonishing fact about the light is that light travels with a velocity of 3 into 10 to the power 8 meter per second. If we calculate in kilometers, it means that 3 lakh kilometers are covered in just 1 second. You can imagine yourself the velocity of the light. It is very much high. Now, if we talk about the light, the optics is that branch of the science. It is that branch of the physics in which we study about all the aspects regarding the light. And optics is broadly divided into two branches, that is ray optics and wave optics. And ray optics is based on the assumption that light travels in the form of rays, and wave optics is based on the assumption that light travels in the form of waves. Now coming back to the nature of the light. Nature of the light for Greek philosophers like pre-Newtonian era, there were philosophers, there were scientists who believed that there are certain particles which are emitted from the eyes and then reflected towards the when they reflected from the object get back to the eyes, then and only then we see the objects. But Newton rejected this concept. Newton gave his own theory. His theory was named as Newton's corpuscular theory in 1676. Newton suggested that light travels from the source in the form of particles, and he named those particles as corpuscles, and these corpuscles travel in the form of straight line. Velocity of the light, he observed that velocity of the light in denser medium is greater than the velocity of light in rarer medium, which nowadays is not correct. But taking this theory as into consideration, he explained the rectilinear propagation of the light, he explained the reflection of the light, but he failed to explain the refraction of the light. He failed to explain why the light travels, why the light bends when it travels from one medium to another medium. So to rectify those limitations of the Newton, another scientist came in 1678, 2 years after the Newton's theory. His name was Huygens. So Huygens proposed his own theory, Huygens wave theory of light. Huygens wave theory of light is based on the concept that light travels in the form of waves. Newton gave the theory that light travels in the form of particles, but Huygens suggested that light travels in the form of waves, and that too in the form of longitudinal waves. And when we talk of the medium, light travels in a medium, which is actually called as the mechanical wave, which travels in the form of medium, and light requires a medium for its propagation. This was suggested by Huygens. So Huygens gave the concept and explained the phenomena regarding the light. Huygens explained reflection of the light on the basis of wave theory. Huygens explained refraction, interference, diffraction. He explained all those phenomena taking light as a wave in nature. But he failed to explain polarization of the light. He failed to explain Compton effect. He failed to explain photoelectric effect of the light. Since Huygens failed to explain certain phenomena regarding the light, so another scientist came. His name was James Clerk Maxwell. In 1873, he suggested that light travels in the form of electromagnetic radiation, and those radiations, electromagnetic radiations with electric field as well as magnetic field, those radiations are perpendicular to each other. Just like this, for example, if we take this as an electric field, if we take this as a magnetic field, and we are traveling like this. If we are traveling like walking like this, it means every angle is 90-degree angle. So electromagnetic wave theory, it suggests us as that the light travels in the form of electromagnetic radiations, and those radiations are perpendicular to each other. The electric field is perpendicular to, and this theory explained reflection of the light, this theory explained refraction, interference, but this theory failed to explain photoelectric effect, this theory failed to explain Compton effect. So to rectify those limitations of the theory, another theory came. The theory was quantum theory of light. It was given by Max Planck. Max Planck suggested that light travels in the form of particles, and those particles, those energy packets, he named as photons or quantas. And he gave the relationship between energy of the photon and the frequency. It is directly proportional. Energy of the photon is directly proportional to the frequency of the photon. This theory explained photoelectric effect. This theory explained Compton effect. But this theory failed to explain how it is related, how it is connected with the wave nature of the light. This theory could not explain why the nature of the light is wavy or it is particle. So some scientists suggested that light travels in the form of particles. Another scientist came, Hughes, and he suggested that light travels in the form of waves. Another scientist, Maxwell, came, he suggested that light travels in the form of waves. And again, another scientist, Max Planck, suggested that light travels in the form of particle. So there was a dilemma between those scientists whether the light has a particle nature or it is a wave nature. So another scientist came, his name was de Broglie. He suggested that light has a dual nature. It can behave as a particle as well as wave. So he suggested that light behaves both particle as well as wave. So he gave the equation lambda is equal to h by mv. So lambda is the characteristic feature of the wave and m is the characteristic feature of the particle. So he combined those two factors and gave the relationship.